The first section in Chapter 7 is titled Integer Exponents. And your objectives today are that you can evaluate expressions containing 0 and integer exponents, and that you also be able to simplify expressions containing 0 and integer exponents. You're going to see me start putting some slides in the lesson that are our objectives. You do not have to write these down, but by the end of the lesson you should be able to do both of these things. So let's review computing some numbers involving exponents. Example 1, we have 2 to the 5th, and hopefully you remember from your work with exponents in the past that the 5 indicates we are going to multiply the base, which is the number 2 in example 1, 5 times. So that's 2 times 2 times 2 times 2 times 2. And when you multiply that out, 2 times 2 is 4, times 2 is 8, times 2 is 16, and times 2 is 32. Example 2, we have -3 raised to the 4th power. So again, that means that we have -3 as our base, and it's being multiplied 4 times. So we have -3 times -3 times -3 times -3. And I'm using the parentheses just so we don't confuse the negative sign in front of the 3 with the subtraction symbol. But -3 times -3 is 9. If we multiply the back two -3's together, we also get 9. And we know that 9 times 9 is 81. Remember, multiplication can be done in any order, so it doesn't matter if you go from left to right or if you group things and multiply that way. Number 3, we have 8 to the 3rd, so it's 8 times 8 times 8. You may want a calculator for this one. We know that 8 times 8 is 64. 64 times the 3rd 8 is 512. And you'll notice with exponents that the numbers get large rather quickly. Next, I want to discuss the difference of example 4 and example 5. For some of you, it may look like the exact same problem, but in fact they are not, and they do yield two different answers. So for number 4, we have -4, and it's being squared. Our base is -4. That means we have -4 times -4, which is a positive 16. The difference, however, in example 5 is that we don't have the use of parentheses. What's happening in -5 is that our base is actually just the number 4. 4 is being squared, but the negative out in front indicates we want to take the opposite of 4 squared. So essentially, if you could rewrite this using parentheses, you would isolate the negative out in front. So then this is like saying 4 times 4 on the inside, take the opposite of that to give you a -16. Make sure you understand the difference between 4 and 5. The base on number 4 is a -4. The base on number 5 is just the 4, and then we're taking the opposite of that. That's what the negative out in front indicates. So let's talk about the 0 exponent first. The rule for the 0 exponent states that any number raised to the 0 power is 1. So for example, 3 to the 0 would be 1. 123 to the 0 power is also 1. Same with negative numbers and fractions. -16 to the 0 power is 1, and 3/7 to the 0 power is also 1. This is a rule you will need to remember, that any number, or product of numbers, raised to the 0 power is 1. To add to the 0 exponent, we also have negative exponents. With negative exponents, you have a non-zero number raised to a negative exponent. It is going to be equal to 1 divided by that number raised to the opposite, or the positive exponent. So we have 3 to the -2. That's going to equal 1 over 3 squared. Notice that we've changed the -2 to a positive, and 1 over 3 squared is 1 over 9. Similar with 2 to the -4th. We're going to write 1 over 2 to the 4th, making the exponent positive. 2 to the 4th, remember, is 2 multiplied 4 times, so we get 1 over 16. If we look at it the other way, if the negative exponent's already in our denominator, we're bringing it back to the numerator. So 1 over 3 to the negative second power becomes 3 to the positive second, or 9. And 1 over 2 to the negative fourth becomes 2 to the fourth, or 16. So let's look at some examples. Let's talk about this real quick. So basically with negative exponents, if we want to simplify negative exponents, you're going to move the power with its base to the other side of the fraction. If it's in the top, we move it to the bottom. If it's in the denominator, we move it back to the numerator, and we're going to make the exponent positive and then simplify the resulting expression. We also need to note that negative exponents do not affect whether the expression is positive or negative. And again, remember, when you're taking notes, you should be writing statements like this down. So now let's look at some examples. We want to simplify 4 to the negative third. So because it's in the numerator, remember we can write it over 1. We're going to move this down to the denominator and make it 1 over 4 to the third power. We can simplify 4 to the third. We know it's 4 times 4 times 4, or 1 over 64. Example 7, we have 3 to the negative fourth. So we're going to rewrite that as 1 over 3 to the fourth, making our exponent positive. So that's 1 over 3 times 3 times 3 times 3 multiplied 4 times, or 1 over 81. Example 8, the negative exponent's already in the denominator, so we need to move it back to the numerator. We're going to move it back to the top. 7 squared, or 49. Number 9, we have negative 8 to the 0 power. Remember what we said about the exponent 0? Anything raised to the 0 power is 1. Another note with an algebraic expression. When we have an algebraic expression and we want to put it in simplest form, we have to remember a few things. First, it can only be written with positive exponents. Each variable should only occur one time, and numbers with exponents are to be simplified. So we don't want to leave 2 to the fourth power in our answer because we know that 2 to the fourth power is 16. So now let's do some more simplifying. These are a little more complex. We have 4x to the negative third y. We can't have any negative exponents in our answer, and here we do have a negative exponent. What we also need to remember is that that negative exponent is only attached directly to the base that it's right next to. So it's this x that's being raised to the negative third power. Because it's a negative exponent, we need to move that down to the denominator. But only the x gets moved. The 4 and the y stay put in the numerator. So we get 4y over x cubed. Remember, we're making our exponent positive when we move the base with the negative exponent. This answer is simplified. 4 is not raised to a power, so I can't simplify that any further. Each variable is only appears once in the answer, and we have all positive exponents. Number 11, we have 3x squared y, all being raised to the 0 power. Remember that anything to the 0 power is 1. So number 11 ends up pretty simple. If you'd like to pause the video and try these next two examples on your own, we have 3ab to the negative second. The b is being raised to the negative second power, so that's what we're moving down to the denominator, leaving the 3 and the a in the numerator. So we get 3a over b squared. Number 13, we have 2 over x to the negative third. The x is being raised to the negative exponent. It's already in the denominator, so we need to move it back up to the numerator, paying attention that there's already a 2 up there. So the 2 is going to stay put in our numerator, and we're adding the x to the third term up top. So we get 2x to the third. When you're evaluating exponential expressions, again, we want to make sure that all powers are positive. Then we want to do our substitution and simplify. Make sure that we're watching out for negatives. So 14 says evaluate each expression for the given values or values of the variables. So we have 3x squared, y to the negative second, and we want to substitute in an x equals 2 and y equals negative 3. But first we want to simplify the expression and get rid of our negative exponents. So the y, because it's being raised to the negative second, is going to move down to the bottom, and it's going to give us a simplified expression, 3x squared over y squared. Now we want to substitute in 2 for x and negative 3 for y. Notice the use of my parentheses, so I'm sure to just be that I'm only squaring the x and the y, and I'm not doing anything with the 3. So on top we get 3 times 4. On bottom we have a positive 9, which becomes 12 over 9. And if we reduce that fraction by 3, we get 4/3. We have x to the negative third, y to the 0. The x is being raised to the negative exponent, so we're moving it down to the bottom. We have y to the 0 over x to the third. Now, you may remember here that anything raised to the 0 power, whether it's a variable or a number, is going to be 1. So now we have 1 over x to the third. So we're just going to substitute in the 2 for x, and we get 1 over 8. That's 2 times 2 times 2. 16, we have x to the negative 1 over y squared. The x is being raised to the negative exponent, so it's going to move down into the denominator. Notice what's already down there, though, a y squared. So in our denominator, we're going to have x to the first, y squared. You don't have to write the exponent 1, but I like to at least initially so that we understand there's just an x there by itself. It's not being squared or anything like that. So then the question is, what's left on top? Well, anytime you get rid of everything from the top, we're going to put a 1 up there. I could have a 1 out in front of this x, 1 times x to the negative first, then maybe it's a little bit easier to see that there would be a 1 left over. So now when we substitute 2 in for x, negative 3 in for y, and that's going to give us 1 over 2 times 9. Negative 3 squared is positive 9, or 1 over 18. A few more examples. If you'd like to pause the video here and try this one on your own, we have y to the 0 over x to the 4th. Remember, anything to the 0 power is 1. The x to the 4th is staying put since it is positive exponent. So we have 1 over 2 to the 4th power. Substituting in the 2 for x. 2 to the 4th is 16, so we get 1 over 16. Example 18, 1 over xy squared, 1 over xy to the negative second. Here the y is being raised to the negative second power, so we're moving that back up to the denominator, so it becomes y squared over x. The x stays put because the x has an implied exponent of 1 that is positive, so we don't need to move the x. So we have negative 3 to the second power over 2. Or negative 9, or positive 9. Negative 3 times negative 3 is 9 over 2. So if we go back and look at our objectives, the first objective was, can you evaluate expressions containing 0 and integer exponents? If you look back at examples 14 through 18, if you understand those examples, then yes, you can. If you have questions on those, we can ask tomorrow in class. Also, are you able to simplify expressions containing 0 and integer exponents? Those were examples 10 through 13. So take a look back at those examples, and if you fully understand those examples, then yes, you can. In class, we'll work on worksheet 7-1A.